Hi, welcome to Physics Lab 03 for Physics 2211. This lab's objective is understanding change in momentum and gravitational systems. Okay, so brief overview here. On the left, we have our first problem where we're trying to determine the mass of the black hole. And then on the right, we have our second problem where we're experimenting with simultaneous orbits. Okay, so for the first problem, the top left, you can see our initial conditions. On the right side, these are the equations we use, the change in momentum equation, the gravitational force equation, and then at the bottom is where we rearranged to find the mass of the black hole. So basically, you're just going to fill in the conditions. So for the momentum initial, momentum final, change in velocity, change in momentum, and then you can get dp dt, which is equal to f net. And then you can use the distance vector, which you can get with the other information I gave you, and then use that to fill it in and get the mass of the black hole. You're going to do it iteratively so that you can average it out, and at the end we got the final mass, which you can see 6.07 e to the 33 kilograms. In this problem, the system was the planet and the surroundings were the black hole. Okay, so for our second equation, we have a moon, a star, and a spaceship. At the top left is our initial conditions. The ones with comments are all just sort of procedural. And then the speed in the x direction and speed in the y direction we played around with and just experimented with to determine an orbit that would work, because this like three-body problem is really difficult to actually do the math to figure out. But what you have to do is you have to make sure that every single object in the system, or in both the system and the surroundings rather, are accounting for the gravitational forces that they exert on each other. So for example, the moon is going to have a gravitational force being exerted by the star and the spaceship. The spaceship is going to have a gravitational force exerted by the moon and the star, and then the star is going to have a gravitational force exerted by the spaceship and the moon. You're going to fill those in with the force of gravity equations and just sum them using sum of the forces. And then at the end, you can get the acceleration of the ship by just doing the F net divided by the mass, and then using your velocity update formula, v final equals v initial plus a delta t. You're going to keep getting your new velocity and updating the positions. After playing around with the numbers, I got the orbit to look something like this, where we are having like an interesting behavior, and both the star and the moon are affecting the way that the spaceship is orbiting. All right, what ifs? So for the first one, discuss how the net force and its parallel and perpendicular components are different from the rate of change of momentum in its perpendicular and parallel components. So in both cases, the parallel components are acting in the direction of the velocity, so they're only going to have effects, or I guess not necessarily the direction, but they're only having an effect on the speed, whereas the perpendicular only have an effect on the direction of the motion. But the difference is that, like, with F net, that's talking about like the actual cause of something, whereas the momentum is talking about like the effect. Like if you look at the effect of the forces, that's going to give you your momentum change, whereas with the F net, that you're looking at like how these forces are changing the way that it's moving. All right, second what if. So imagine that the system has a black hole, a star, a planet, and a moon. If you wanted to predict the motion of the entire system, what would you need to include in your computational model? So all of your interactions are going to change, because with a new object, every single other object is going to differ. So with the star, now it has 3 objects having a gravitational force on it. The planet also has 3 objects rather than 2, and you have to go through and update every single one. And then which ones will be more dominant? If you have a larger mass, that's going to mean you're going to exert a larger gravitational force, and at the end of a long period of time, it's going to have a greater effect on the system. Thank you for watching.